Welcome to 3.1. We are talking about graphing. So today we will plot ordered pairs, determine whether an ordered pair is a solution, graph linear equations, and graph nonlinear equations. That's a lot. An ordered pair is xy, okay? Or it is two numbers like 0, 5, -1, -3. Okay? So that's what, when you hear ordered pairs, think two numbers with parentheses. It's not related to the inequalities, parentheses. So think of two numbers with a comma in between them and parentheses around them, and it tells you where a point is on a graph, okay? So, and then we will determine whether an ordered pair is a solution, graph equations, and that will be all, okay? So the rectangular coordinate system, an ordered pair, x comma y. So when you do see numbers, you can always right above those numbers, put an x first and then a y. My x for this point is 0, my y for this point is 5. That will make more sense later. So an ordered pair are two numbers associated with a point on a graph. The first number gives the horizontal location of the point. The second number gives the vertical location of the point. Okay, so y is vertical, x is horizontal. All right, okay. So we graph on a plane. It's a flat surface extending forever in 4 directions. If you think about this is a number line, right? We've been working with number lines. We might feel okay about number lines, right? But then, so that's a horizontal number line. But then we do this to the number line. And you have a coordinate system or a coordinate plane. So all I did was I took this number line and I added a second number line. So it's two number lines that cross. The place where it crosses is the origin. Yeah. So the origin is the point where the two number lines intersect. Each number line is called an axis. The horizontal number line is called the x-axis. Horizon, think of like a sunrise. The sun rises over the horizon, the sun sets across the horizon, right? Horizontal, that's how I remember it. And then the y-axis is vertical, up and down. So this is my y-axis, okay? That's my origin where they cross, x-axis, y-axis. It will become very natural, okay? The coordinate is the number in an ordered pair, x coordinate or y coordinate. So when you see the ordered pair, you see a open comma symbol, then you see the x coordinate, whatever that number is, you see a comma, and then you see the y coordinate. The quadrants are 4 regions created by the intersection of the two axes. So here we have quadrant 1. It goes in reverse clockwise position or counterclockwise direction. So here's quadrant 2, here's quadrant 3, here's quadrant 4. Good. So quadrants are what the plane is broken into when we create the two intersecting lines. All right, I will give you an example of a point in each of the quadrants. This is maybe the point 2 on the x, 2 on the y. This would be the point -2 on the x, but it's still +2 on the y. If I went into quadrant 3, that's actually negative on both the x and the y, so that would be -2, -2. And then this point not very accurate because I put it above that -1. This point would be positive x, negative y. So that's how the quadrants determine whether a term is negative or positive. Good? All right. So each point is a direction on the plane starting from the origin. So if I go 2 to the left on x and up 2 on y, I'll get to the point 2, 2. All right? We are going positively to the right and up, negatively that way. This way is positive, that way is negative. We'll keep covering this, don't worry. I know this is fast. So to graph a point corresponding to an ordered pair, start at the origin, move x units to the left if x is negative, or to the right if x is positive, move y units up if y is positive, down if y is negative. So another way to say that is we have our coordinate plane. This is positive x, this is negative x, this is positive y, this is negative y. All right. And this is the origin where you start. So here are the quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Sorry. The x-axis, the y-axis, and then the point 0, 0 is your origin because you have moved 0 spaces from either place. Okay. Definitely stop me if you have questions. Okay. Example 1 asks us to plot each ordered pair and state which quadrant in or on which axis the point lies. So it might not even be in a quadrant. It might be on the x-axis or on the y-axis. Remember, this is the x-axis. This is the y-axis. Good. All right. Point A is 4. Remember, your first number is always x, your second number is y. So from the origin, I'm going to go to the right 4 because this is positive x, this is negative x, this is positive y, this is negative y. Okay. So 4 on the x-axis, 2 on the y-axis. That's the point A or the point 4, 2. We went to the right 4, we went up 2. Letter B is -3, -2. So starting always from the origin, I'm going to go -3 on the x-axis, -2 on the y-axis, and where they join. So to the left 3, down 2, and where those two would join together, that's -3, -2. C is 2, -3, so I'm going to go out 2, +2 on x, -3 on y. So out 2 on x, down 3 on y. That's the point 2, -3. D is the point 0, 4. So I'm not going to travel anywhere on x, 4 on y. 0 on x, 4 on y is right here. And then 5, 0 is kind of the opposite, where I'm going to go 5 on x, 0 on y. So 5, 0 is going to be on the x-axis. 0, 4 is going to be on the y-axis. 2, -3, if we count the quadrants, here is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Sorry, it was like I was going to do Roman numerals, but I really don't like Roman numerals. But I think that's how you do quadrants. So we're just going to call it quadrant 1. So 2, -3 is actually in quadrant 4. -3, -2 is in quadrant 3. And 4, 2 is in quadrant 1. Any questions about plotting an ordered pair? You can also call it graphing an ordered pair or graphing a point. All right, so those are the quadrants and the axes. This is not in a quadrant, this is just on an axis. This is not in a quadrant, it's on an axis. Good. All right, so when we introduced the learning objectives, we said plot ordered pairs. We've done that, right? Next, it says determine whether an ordered pair is a solution because we are going to take linear equations and we are going to graph them. That means that you can take something like this, you can graph it, all right? So let's use Desmos. And feel free to follow along with me. It was 2x plus 5y equals -4. Okay, you just put that into Desmos, it gives you a line because every value, every point on this line, and there are many, many points, infinite number of points, is true for that equation. Okay, so that point -2, 0 is true for 2x plus 5y equals -4. So first of all, 2x plus 5y equals -4 is this giant line that goes on forever in both directions, okay? And, sorry, -2, 0 is on that line, so we say is on the line 2x plus 5y equals -4, or -2, 0 is a solution for the equation 2x plus 5y equals -4. We see what that means on the graph, right? Because when we graph it, the point -2, 0 is part of that graph. But what does it mean for algebra? Okay, -2, 0 is a solution for 2x plus 5y equals -4. That means, remember, what does the -2 mean? The -2 is actually an x value. Yeah. And though 0 is actually a y value. So that -2 is on the x, that 0 is on the y. If I look at it on the graph, if I am at the origin right here, on x I go -2, on y I do not move off of 0. I'm at the point -2, 0, okay? That's how we got -2, 0 is right there. We started at the origin, we went to the left 2. So -2 is my x, 0 is my y. It's a solution of 2x plus 5y equals -4 because if I write this, and instead of putting in x and y, I put in -2 and 0, I'm going to get a true statement. 2 times -2 is -4, 5 times 0 is 0, -4 equals -4. It will be true because that point is on that line. That means it is a solution for 2x plus 5y equals -4. Now, let's see if they ask if the point 3, -2 is a solution for 2x plus 5y equals -4. Let's do this first with Desmos, okay? So again, our numbers were this equation, and then they asked for the point 3, -2. If you were just to guess 3, -2, Is it on the line? It looks like it is on the line. So you can graph it and decide that way, or you can put it into your original equation. 2x plus 5y equals -4, but instead of x and y, we have the numbers 3 and -2. 2 times 3 is 6. Tell me when I get something wrong. 5 times -2 is -10. 6 plus -10 is the same as 6 minus 10. 10 minus 6 is 4, but the 10 is negative, so that is -4 equals -4. So we would say yes, it is a solution of 2x plus 5y equals -4. We can determine it on the graph by graphing it, or we can determine it algebraically by doing that work right there. Okay? Why is the -2, 0 true? If you can just input the numbers into the equation to get the answer. Oh, because that's a good question. So you asked if you input the numbers into the equation to get the answer, why -2, 0? Because every point on the line is true. So because you have an x and a y, you have to have a value, whatever your x is, there's only one y that is true for that x. Whatever your y is, there's only one x that is true for that y. So you can put in y equals 0 and solve for x, or you could put in like x equals 0 and solve for y. So we can make up any point and decide whether or not it's true, or we can just say when x is 0, for example, right? And I don't know what y is, I can find y. That would be 5y equals -4. So y equals -4/5 when x equals 0. So that means that's the point 0, -4/5. So you can do that with any number. You can find any number for like, what is y when x is 0? What is y when x is 1? What is y when x is 2? What is x when y is -3? They are both true. No, they just want to know the good question. So the other question was, they are both true, but only 3, -2 is the solution? No, they are both solutions, is a solution. So they didn't say the, just a. So that's a very good question. Remember, when we look at the whole line, every line on here is a solution. This is a solution. This is a solution. So there's infinitely many solutions. They just picked one point that was easy to graph and said, is it a solution? This is a solution. This is a solution. If you put in -30 for x, you'll get out 11.2 for y. So all of these are different solutions. They're not just one, they're just asking you to show that you know how to check if it is one of the solutions. But there are many, many solutions. Good question though. All right, so a solution, not the solution, but just a solution. If you want to go straight to graphing because it's kind of easier, you just put in 3x minus y equals 5. And then you have the point -1, 6. So if we had to go to -1, +6, do you think that that's going to be a solution? It is not. So they said determine whether -1, 6 is a solution of 3x minus y equals 5. A solution will be on the line. That's what the line means. The line is every point that is true for 3x minus y equals 5. So let's rewrite it. 3 times -1 minus 6 equals 5. Remember, that's our x, that's our y. So I'll put them in. 3 times -1 minus 6 is 5. True or false? 3 times -1 is -3, minus 6 is 5. This is not true, right? So we would just say that is not a solution. It's just as legitimate to graph it as it is to do it algebraically. So what we've been seeing are linear equations. That just means there's one x, there's one y, there's no other variable, and the x hasn't been raised to a power. A linear equation in two variables can be written in the form ax plus by equals c, where a, b, and c are real numbers, and they are not both 0. If these were both 0, it would just be, it wouldn't be an equation. So this is the standard form of linear equations, ax plus by equals c. And this is how we graph them, okay? So you are welcome to, again, we have y equals 3/4 x plus 3. On Desmos, what I would do is y equals, you can either include the y equals or you can just start straight away with the equation. So we have 3/4 x plus 3. That will graph it just as well as y equals 3/4 x plus 3. They do the same thing. Good. So it just asked graph a linear equation, y equals 3/4 x plus 3. You don't need those parentheses if you don't want them. It will graph without it. And I just used the slash bar that's part of the question mark button to make a fraction. So it says graph the equation y equals 3/4 x plus 3. Here it is in Desmos. And then they kind of highlighted for you this point and this point. So those are 2 points. They are the x-intercept and the y-intercept. So those are 2 points that happen to be for this graph whole numbers. And this just means that when x is 0 for this equation, y will equal 3. When y equals 0, x will equal -4 for this equation. Good. If you want to graph it by hand, you can make a table of values. X, your equation, y equals 3/4 x plus 3, and then your point, your ordered pair. Okay, you decide what you want to put in for x, you put that x value into this, and you are outputted a y, right? Y equals 3/4 x plus 3 when x is 0, let's say. Okay, and then you just make up an x. When x is 0, y will equal 3/4 times 0 plus 3, which just becomes 3, right? So that means my x is 0. When my x is 0, my y is 3, because that's what I got when I put in 0 for x. When graphing by hand, it's good to pick 0 because it's easy, and then pick a positive number and pick a negative number. Technically, you only need 2 points to graph a line, right? But you want to pick points that you want to pick 3 just to make sure, right? And if we are looking at this, this has a fraction with a bottom term of 4. So I think it would be easier, instead of saying 3/4 times 1 plus 3, 3/4 times 4 plus 3 is going to be easier, right? So if x is -4 for a negative number and x is +4 for a positive number, that will help me simplify the fraction immediately. So 3/4 times -4 plus 3, that means I get to cancel these, right? But then it just becomes negative because a negative divided by a positive is a negative. So 3/4 times -4 becomes -3. Is that okay? This video will be on Blackboard, yes. Good. So 3 divided by 4 times -4 becomes -3, because you can either take it like 3 divided by 4 times -4, or 3 times -4 divided by 4. or 3 times 4 divided by -4, which is -1. Multiply by 3, you get -3. Hopefully that helped and did not confuse you. So -3 plus 3 becomes 0, right? So this one is actually the x is -4, and when x is -4, y is 0, because -3 plus 3 is 0. We'll do it again. Here I said I chose +4. So when y equals 3/4 times 4 plus 3, that means y equals 4 divided by 4 is just 1. 3 plus 3 is, 4. 3 plus 3 is 6. So when x is +4, y is 6. You can use any number you want for x. It's just easier when you have a fraction to use that denominator as your term, because then you'll get whole numbers over here. And then so our terms were -4, 0, 0, 3, and 4, 6. If we go back to Desmos and we plot the points, -4, 0, 0, 3. Oops. Should label them. -4, 0, 0, 3, and what was the other one? 4, 6. You should see that they are all on the line. So that's how you graph them. You can put in a value for x and find y, and you can put in any number, any real number, okay, to find y. But it's easiest to do 0 and then do really small numbers, or if it's a fraction, do that bottom of the fraction number. That'll help. So this example 5 says graph the linear equation 2x minus y equals -4. What you can do is first solve for y. Feels very crooked. I apologize. So right now, 2x minus y equals -4. It's not easy to find y, right? If I just plug in a random x, but we can solve for y as the first step of this equation. 2x minus y equals -4. I want to solve for y. I want y alone, so I'm going to subtract 2x from both sides. -y equals -2x minus 4. I just like having x in front. And then divide by -1 to find y. So a -y divided by -1 gives me the positive y that I want. So y equals -2 divided by -1 is a positive 2x. -4 divided by -1 is +4. So another way to write 2x minus y equals -4 is y equals 2x plus 4. I'm going to show you in Desmos that those are the same graph. All right, I'm going to erase this one. And I know we're going super fast. I apologize. So we said y equals 2x plus 4 is what we got when we solved it for y. And our original equation was 2x minus y equals -4. So you see that that line is purple. If I remove the purple line, it's black. So those are the same equation, just two different ways to write it. They both have the exact same value, and it has the same value as 2x plus 4. So if you set it equal to y, you don't need to put y equals into Desmos. Those are all three the same. So we need to graph it by making a table, is what we would call what we just did. We just made a table because, do it over here where I have one straight line. We picked a value for x. We plugged it into y equals, and we got out a coordinate point. All right. Again, I said I like doing 0. So when x is 0, y equals 2 times 0 plus 4, which is, so this is now just x comma y. When x is 0, y is 2 plus 4, which is 6, right? No. Yeah? 2x plus 4. Nope, it's not 6, it's just 4. Did anybody else? Did anybody catch that before I did? Really wanted to add 2 and 4, but you can't. It's just 4. Because 2 times 0 is 0. 0 plus 4 is 4. All right, another good one to do if you don't have any fractions is just -1 and +1, because those are going to be easy numbers to put into that equation. So if I put -1 into that equation, I get y equals 2 times -1 plus 4. 2 times -1 is a -2. -2 plus 4 is just 2, right? So when x is -1, y is 2. Down here for 1, we have y equals 2 times 1 plus 4. So that means when x is 1, 2 is, we have the 6 I wanted. Because 2 times 1 plus 4 is 6. So I should be able to see on the graph the points -1, 2, the point 0, 4, and the point 1, 6. We will put those 3 into Desmos. So first it was -1, 2. Then we had the point 0, 4. And then we have the point +1, 6. So you can see that they are all on that line. I found 3 points. I only need 2 to graph it, right? To graph just means to make a line between the points connecting them. Intercepts are points where the graph crosses the x-axis and points where the graph crosses the y-axis. We covered this a tiny bit already, but to find an x-intercept, make y 0 and solve for x. To find the y-intercept, make x 0 and solve for y. So you'll see that here, when x was 0, we got the point 0, 4. That's the x-intercept because that's where it crosses x. If I put y in for 0, or 0 in for y, then I'll get the y-intercept. Example 6 says graph 2x equals y by finding and plotting the intercepts only. Okay. So instead of immediately graphing, on Desmos, let's just see what we find for the x-intercept. All right, 2x equals y. First, we're going to set it equal to y. It's already equal to y. It's just reversed. So you can just write it as y equals 2x if you want. Okay. So when our x value is 0, y equals 2x becomes y equals 2 times 0. Good. 2 times 0 is 0. So the intercept, there's only one. 0, 0. So not a great example of that. Let's take another one 1 second. Let's do y equals -4x plus 8 and plot the 2 intercepts. All right, so there's going to be an x-intercept and a y-intercept. To find my x-intercept, make x 0. Y equals -4 times 0 plus 8 becomes what? 8, right? So that means my x-intercept is 0, 8. Okay? For my y-intercept, I need to make y equal 0. My y is always my second number. So if my y is 0, I need to find my x. So now 0 equals -4x plus 8. Is that okay? Instead of putting a number in for x, I put 0 in for y. I don't know what my x is, but I'm going to figure it out right now. Good. So I have 0 equals -4x plus 8. Let's solve for x. So I'll subtract 8, -8 equals -4x. We're solving for x, so let's divide by -4. -8 divided by -4 is a +2. X is 2 when y is 0. Let's see if that is true. So our equation was y equals -4x plus 8. They asked us to find the intercepts. One intercept is 0, 8. The other intercept is 2, 0. So that's what it means when it's find and plot the intercepts. Put in 0 for x, see what you get out for y. Put in 0 for y, see what you get out for x. Example 7 and 8 and 9 are no longer linear equations. So they asked us to plot ordered pairs. We did that. Determine whether an ordered pair is a solution. And remember, there are many solutions. Every point on that line is a solution. Graph linear equations. That means the equation is a line. X is not raised to any power. Y is not raised to any power. And now we're on to graphing nonlinear equations. Linear means line, right? Nonlinear means it's not going to be a line. It might be a curve, and it might have a turn in it. So example 7 says graph y equals x squared. Good. This is not linear. They are linear if your exponent, your highest exponent is a 1. Because this is a 2, because x has been raised to the second power, this is called nonlinear or quadratic, okay? It's not a line. We can still plot points, but it's not going to be a line. So if I had to do it without Desmos and I was just making a table, you're still just plugging in an x. Y equals x squared. Sorry, I should not have drawn that like that. And then x, y. Good, so let's find some points. When x is 0, y equals 0 squared, which is just 0, right? So our first point is going to be 0, 0. Plot it like that. There's 0, 0. What about if x is -1? I said I liked using -1. That means y is equal to -1 squared, which becomes 1, right? So my point is -1, 1, because that's x, y. -1, 1. What if x is +1? I like to go with the easiest numbers I can. So now y is 1 squared, which is 1. So that means my point is 1, 1. And you can keep going. You could say, what if x is -2? y equals -2 squared, which is 4. So that means I have the point -2, 4. Just guess and say it's right below the 5. And then +2 is going to be the same thing, right? Because we're just squaring it. So 2 squared is 4. So we have the point 2, 4. So we're able to graph it. And it's not a straight line. If I put y equals x squared into Desmos, sorry, x, to put the square into Desmos, you just hit shift and then the number 6, okay? And something else, oops, that is good to know about Desmos is you can press that edit list gear. This may offer you a table of values. So if you're like, what is y when x is 100? Y is 10,000. Good. If I had the graph y equals -2x plus 1. Good. What is the table for that? If x is 20, y is -39. So the table gives you numbers if you need to, if they're going to ask you when x is 0, what is y? Good. So there's a table option. It is hard to go back. You kind of just have to go like this to get back to the actual graph, as far as I know. Yeah. All right. So there is y equals x squared, or just x squared on Desmos. It matches what we found, right? And then, since we only have 4 minutes left, graph the absolute value equation y equals the absolute value of x. So we'll just try to do these quickly. So if I was going to make a table, when x is 0, y equals the absolute value of x is still just going to be 0, right? Because y equals the absolute value of 0 is 0. If x is -1, the absolute value of -1 is 1. +1, the absolute value of 1 is 1. So it's a bit like the x squared, right? Where you have you start at the origin and then it's mirroring itself. But it's actually going to mirror itself more like this. And you can put that into Desmos as well. Then you have y equals the square root of x. We will put these into Desmos. So we said y equals, and if you are not sure how to put it into Desmos, go down here and hit show keypad. This is your absolute value bar, the absolute value of x. Here is y equals, here is the square root of x. Good. And you can get tables. So when x is 0, y is 0 for this one. When x is 1, y is 1. When x is 2, y is the square root of 2. Up here, you can look at the table as well. Good. All right.